single semiconductor fab, just one, uses as much water in a single day as an entire Indian district. It consumes more electricity than some of the country's largest steel plants. It demands air cleaner than an ICU, and the precision lighter than a surgeon's hand, and reliability more consistent than a Swiss clock. And here's the real twist. India doesn't need just one of the semiconductor fab, India need five of them. But what if I told you calmly, logically, and with facts that India's semiconductor dream may be structurally impossible right now?
See, China started their semiconductor program 20 years back. They're still not able to compete on that.
Not because we lack money, not because we lack talent, not even because we lack technology, but because we are missing the invisible foundation that no one talks about. Yet, every successful chip ecosystem silently depends on it. Hello everyone, my name is Ravish and I welcome you to TalNurt's professional learning series where we help you to grow as a leader, builder and thinker. Let's break this down in simplest, cleanest and most light way possible. Number 1. The stakes. Semiconductors are the foundation of modern life. They run our smartphones, the electric vehicles, defense system, AI data centers and even the satellites. The world needs more chips very urgently. Countries everywhere are racing to build the fabs. And India wants to join the league as well, even more faster. But here's the part almost no one talks about and says out the loud. A semiconductor fab isn't just a factory. It's a precision ecosystem where a living, breathing network of infrastructure which includes chemistry, logistics and reliability. An ecosystem can't be built with the subsidies alone. They require foundation far deeper than funding. So what exactly a semiconductor fab is? Let's break it down in a very simplest way. A semiconductor fab is a place where we build the structure wafer thinner than a coin. To manufacture a modern chip, you need water that is cleaner than anything exists in the nature, a stable electricity, and the air with fewer particles than a hospital's operating system. Also, the machines are so to be sensitive that they can defeat the vibration from the train passing miles away. This is a process where even a single dust particle, voltage dip, or a delayed gas cylinder can destroy crores worth of wafers in seconds. And that's why even today, only 5 countries on this planet can truly run cutting edge fabs successfully. Now the question is how a chip is actually made. Before we talk about why the fab struggles, let's just try to understand what actually happened inside one of the semiconductor fab. Because this alone explains why fab demands perfection. Every chip in your phone, your laptop, your EV starts from something unbelievable. Simply a sand. The silicon dioxide in that sand is melted, purified and converted into ultra pure silicon, one of the purest material human can ever create. This silicon is then sliced into water-thin disc, 300 millimeters wide and less than a millimeter thick. Inside a clean room, each wafers become the foundation for up to 35,000 individual chips. And here's where the magic begins. First, the wafer is coated with photoresist, a specific chemical layer. Then, using microscopic patterns of light, the wafers is exposed, developed and etched. This creates the first layer of the chip's conductor structure. The patterns hundreds of times thinner than the human hair. After that, doplants, special atoms are implanted into silicon to give certain regions more conductivity. Then the process repeats and repeats and repeats, heating the wafers to up to 1100 degrees Celsius, sometimes 27 times, taking 200 plus measurements, performing 26 separate exposures, layer after layer after layer. By the end, the wafer goes through 700 individual processing steps across 14 weeks of continuous fabrication. Only then do we get the real structure of modern chip. A 30-layer mini skyscraper where every layer has its own electric function and all layers must align with atomic precision. This is why semiconductors are called the building blocks of the future and why manufacturing them is one of the hardest engineering challenges on earth. Let's just put a spotlight on India and understand the challenges it will face. We're going to break it down in simple real world obstacle and shows what actually happens inside the countries that succeeded. Number 1, the water. Let's start with the most overlooked requirement of them all. A single advanced semiconductor fab consumes 20 million liters of ultra pure water every single day. To meet this demand, Taiwan spent 40 years building massive recycling and purification system. Intel's fab in Arizona requires 95% of its water on site. Now contrast to that with India's where we are losing 40 to 50% of our municipal water to leakage and cities are drying up. So here's an uncomfortable question. If we are struggling to stabilize the drinking water, how do we stabilize water for semiconductor fab? We need water that needs to be cleaner than anything found in the nature and far more precise than what even a medical labs require. This is the first invisible bottleneck for India to manufacture its own semiconductor chip. Number 2, power. A cutting edge fab needs uninterrupted electricity 24 into 7, 365 days a year with fluctuations less than 0.1%. Anything beyond that can corrupt an entire batch of wafers. That's why TSMC of Taiwan runs on dedicated power grids and even operates its own private power plant. Samsung uses multiple reductants grid so that even if one fails, production never stops. India is rapidly improving its power infrastructure, but many regions still experience plant outages for maintenance or load management. You will often hear announcements like power will be unavailable from 2 pm to 6 pm due to scheduled work. These interruptions are normal during an upgrade journey and they highlight why building semiconductor grade reliability requires as much as more stable, high precision and power ecosystem. And as I said, in the world of semiconductor manufacturing, even a zero point 0.1 second voltage dip means millions of dollars lost, weeks of production delayed, and entire wafer destroyed. No global investor will gamble billions on fab that can be shut down by passing voltage fluctuations. Power reliability isn't a luxury. For fab, it's oxygen. Number 3, cleanliness. Next comes the requirement most people never think about, cleanliness. A semiconductor clean room is one of the cleanest environment on earth. It allows just one dust particle per cubic meter. For context, the air in Mumbai can have 25 million particles in the same space. To build a clean room that meets Fab standard, you need vibration isolated floors, negative pressure rooms, sealed contamination proof construction, and dust particle free supply chain from end to end. Now compare that to how most manufacturing units in India operates today. Processes can vary from shift to shift. Environmental conditions like dust or humidity aren't always tightly controlled, and the quality routineness differs across facilities. All of these works perfectly well for regular manufacturing, but for semiconductor fab requires a special layers of precision, uniformity, and contamination control that goes far beyond a standard industrial operation. This isn't criticism, this is physics. You cannot build atom layer precision in environments where dust, vibration, and inconsistencies are daily realities. Number 4, workforce. Now let's talk about the talent. India produces engineers in huge number, but semiconductor fab does not need generic engineering talent. They need nanofabrication specialist, plasma process expert, material chemist, lithographic engineer, and contamination controlled specialist. The kind of ultra specific talent India produces are maybe around 200 people a year. A single advanced fab needs 10,000 plus trained specialists and technicians. This isn't a lack of intelligence, not even the lack of capability. It's a lack of specialization into deep niche expertise that take decades of ecosystem building to produce scale. And finally, let's talk about the most invisible and most fragile pillar, the supply chain. A modern semiconductor fab relies on staggering ecosystem of material it uses. It required 300 plus specialties of chemicals, rare gases like neon and xenon, EUV compatible acids, and ultra pure solvents that only a handful of countries can even produce. Today, India does not manufacture nearly 90% of these materials. That's why fab in Taiwan, Korea, and Japan are surrounded by tightly integrated chemical supplies, all located within hours of fabs. Because in chip manufacturing, if one chemical does not arrive on time, the entire production line stops. A semiconductor fab does not run on best efforts of logistics. They run on precision logistics, where every cylinder, every chemical, every delivery must be perfect every single day. And now, the final and perhaps the most unspoken barrier, geopolitics. To manufacturing advanced chip like 5 nanometers or 3 nanometers, you need one machine, the EUV lithographic system. It is built by just one company in the world, ASML in Netherlands. Every machine costs over 200 million US dollar, takes 2 years to deliver and tightly controlled by US export regulation. Even China, with far greater leverage, deeper manufacturing ecosystem, struggles to access them. So, realistically, India won't be getting EUV machines anytime soon, which means India's semiconductor journey will begin at 28 nanometer and above. Now, the question is, are 28 nanometers and above chips useful? The answer is absolutely yes. It powers cars, appliances, power electronics, telecom equipments. These are the huge market. Is it cutting edge? No. That's a strategic reality we must acknowledge. Taiwan doesn't become the world semiconductor capital by luck. It became because it spent 4 decades building the foundation that Fabs depends on. From 1980s to today, Taiwan invested relentlessly in massive water recycling infrastructure, rock solid power reliability, universities producing thousands of semiconductor specialists, clean room construction expertise, predictable industrial policies, and defense supplier networks located right next to the fabs. Taiwan never began by building 20 billion fab. It began by building the ecosystem that makes 20 billion fab possible. That's the chapter India is trying to skip, and the chapter we need to study the most. Now, let's talk about the hopeful and realistic opportunity. There are areas where India can absolutely lead the world, starting right now. India is already a powerhouse in chip design, with more than 50,000 engineers designing processors for every major global company. We can dominate in chip design and IP development, OSAT, which includes testing and packaging, EV and power electronics chips, defense grade semiconductor, solar inverter and energy chips, and legacy nodes like 28 nanometers and 40 nanometers, which still power massive industries. And here's the best part. These category does not require EUV machines. They don't need NASA level water purity. They don't demand $1 billion hyper clean rooms. They require discipline, process, consistency, and long term planning, not miracles. India can win this segment today. Build scale, build expertise, and use them as a stepping stone towards more advanced manufacturing tomorrow. Because chips are the foundation of modern life, every phone, laptop, car, aeroplane, medical device, even AI runs on semiconductor. And these chips can't be made in a normal factory. At the end of the day, a semiconductor fab isn't just a building. It's a promise that water will never run out, that power will never flicker, that chemicals will arrive on time, that logistic, engineering, and reliability will work together like a perfectly turned machine. Before India builds a fab, India has to build something far deeper: the trust. Trust in its infrastructure, trust in its consistency, trust in the system that keeps a fab alive, trust that will work today, will work 10 years from now, because that is a real semiconductor revolution. Not the machinery, not the building, but the foundation of reliability beneath it. So, what's the takeaway? India can become a semiconductor power, but only if we build the invisible foundation first. And here's how you will fit into the journey. If you are a student, specialize early. Specialize in material science, chip design, nanofabrication, and process engineering. If you are a policymaker, prioritize the reliability over the public relation. Stable water, stable electricity, and stable policy. And if you are a business leader, double down on chip design, testing, and packaging, areas where India already has a real competitive edge. India does not need a miracles. It needs discipline, consistency, and ecosystem building. That's how we unlock the semiconductor future. If this video brought you the clarity, hit the like button, share it with someone working in tech. They will thank you for it. And also tell me in comments, should India prioritize chip design or chip fabrication? Your insight might just shape the next episode. This was TalNurt's professional study by me, Ravesh. If you found this useful, join me every week as we break down powerful business insights that help you to grow as a leader, builder, and thinker.